Hello everyone, welcome to your next section. In this one I'm going to introduce you to a new plotting type called the bar plot, and we're going to build our code in a way that we can, essentially take any other type of plotting type in Matplotlib and structure them simply and easily to use. So you're not building a new, essentially the flow in which you're thinking of building a figure is going to be a little bit more standardized and easy to use, rather than having to worry about, specific function parameters within each of the, plotting types you're using. You're just going to stack on methods on top of each other. So your code becomes a little bit more malleable. You'll be able to almost use the same code base for many different types of plots, rather than having a very different code base for many different types. So that's what I'm hoping you'll gather from this. So in this class, we're going to talk about the features of a box plot. So you're going to have a bit of a statistics review with this, which should be just fine. It's important to have. We're going to talk about the features of a box plot with an example, talk about how to create box plots in Matplotlib, because it's different in concept and design when compared to, let's say, a scatter plot or something like that. And then we're going to show you additional styling options after we've built the structure for you to adjust styling in very simple ways. So first and foremost, we want to talk about quartile ranges. So when we talked about these quartile ranges, essentially what they mean are if you have a distribution of data, you have a bunch of heights for people, and you wanted to know how much of your sample was above or below 5'5". You can use percentiles in order to do that. Percentiles are essentially quartiles, but quartiles are at every quarter across 100%. So the 25th percentile, the 50th percentile, the 75th percentile. These are important features in a box plot. The next concept we're going to talk about are whiskers, which are a visual representation of box plot quartile ranges. They look like little lines. You can also call a box plot a stem and leaf plot, by the way. So we're going to be looking at these quartile ranges, these whiskers. We're going to look at concepts of outliers, which are how outliers are represented in box plots. In this case, box plots show all outlier points if they're at least 2.5 times higher than the outer quartile ranges, the 25th and 75th percentiles. And we might see them in our plot, we might not, but it's important to know what those dots are when you see them. And lastly, you'll see a very straight line in the middle of the box of the stem and leaf plot, and that is going to represent your median. Turns out that medians are really good when you have data that is, has a lot of outliers in it, because you have 6 or 7 data points that are so extreme that it throws everything else off. Medians tend to help avoid that skewness in data. Meaning, there's lots of data that's influencing the results of everything else. So median can be it's also a nice thing to learn before we move into box plots, getting a little bit of a refresher on statistics. So what you have in front of you is a sample box plot that we are going to build in Matplotlib after this section. You are seeing one box in the box plot. What you see is the yellow line is representing the median for this data. This happens to be iris data set. So we are looking at, I believe, petal length for all flowers to see what the descriptive statistics are for this in a visual representation. The first 2 lines above and below that make up the box are your 25th and 50th percentiles. So these are your second and third quartiles, essentially. So 50% of your data lies within a little under 2 and a little above 5. You then see these lines with horizontal lines at the end of them. These are your whiskers, and they are showing you how far your final 4th and 1st quartiles are. So the range of data between the 75th quartile and the top and the 25th and bottom. Okay? That is what these are showing. You'll also notice that we've added a label and we've added a title. These are 2 features that we're going to show you how to do once we show you the architecture of building a proper figure in Matplotlib, and in a way that's organizable so you can apply it to other data types. No problem. You're only going to augment one line, essentially. So with that, why don't we move into our syntax section for this. This is basically our coding area where we're going to start to look at how to build one of these. Okay, this is how we build it. So remember, so we weren't into our iris dataset. We used the website for this one. You will also notice that I converted our data types as into a category data type for species, and I replaced the labels with these category codes, 0 to 1. Let's just remove this for now and see if that changes anything. I think it will, but we'll see here. The next thing I did was I used this .figure function on our plot. Now with .figure, you can set some like full parameter information. So if you have subplots, let's say, and you want to, adjust how big the entire figure is, not just each of the individual ones, you can use figure in order to do that. You can add your then add your plots individually using the .add subplot function. And notice that there's not commas here. It's the same basic thing. It's expecting 3 numbers and it commas it for you. But for here, I create an access object that has access and data associated with it. So in our figure, I say add a subplot to this position, first row, first column, with 1 row, 1 column, and the first position there. I then give it all of the petal length data because we're just going to do 1 here, and we'll see what that looks like. We do notice here that I use the access object, and I can then adjust additional information. So this, without just the box plot, will show just that information there. And then I said, hey, I don't want to have a titleless data set. I want to call it iris data set. I want my font to be this font, and I want it to be bolded because it's important. And let's just call this flower. So now I'm setting very specific elements to my object for this data frame, or for this figure, and we can do all kinds of different stuff here, all right? If we do this, what do we end up getting? We end up getting our bolded title, our label flower. Let's see if we can do other things like box plot, petal length, and sepal width. Let's see if this works. What do we get? It's just loading right now. It takes a little bit of time. We get too much information because it's not box plotting properly. It's giving basically a box plot for each specific flower, and that doesn't make sense. So we need to adjust this a little more. The point of me showing you this really is that this is how you can create a simple box plot, and this is how you can start to adjust features within the box plot. There is going to be something within .access or box plot in order, and feeding in the proper data in order to get, positioned box plots all together, or different types or something like that. Maybe we try group by species. See if that works. No, it won't, because it's a different object type. Doesn't matter, guys, for now. That is really want to show you. The real point is this here, where we have created a figure and access, where we have our total figure dimensions that we can adjust, and then we can start to create different graphs and adjust each of them individually. So we call this, we can call this access 1. And if we had another graph that was a line graph, we can just go, figure.add subplot 1, 1, 1. But now we have column 2 and the second one, and then call this access 2, and then build a whole other graph next to it that has different values. Let's just change them up here. And iris data set test, and we will get rid of font weight and see what happens. We need to make sure that these are all access 2 as well. Okay, we have 2, and they do like slightly different things here, as you can see. So this is when we want to continue to adjust the figure parameters as well as our access parameters for each in order to get something working. Okay, guys, with that, let's do a recap. All right, and everyone, in this section, we learned how to create box plots. We understood we learned how to interpret what a box plot is actually telling us, what these whiskers mean and what median is, how quartiles are all working and what a box plot is trying to communicate with its style of visualization. We learned how to code a box plot and how it's different than a line, traditional simple line graphs or bar graphs. However, one thing that we did also learn that was super cool was probably a very optimal way to organize and maintain your visualization data code, including figure and subplotting, so that you mostly just need to adjust the type of plot you're using and then play with the axis parameters for that plotting type in order to get it to just the way you like it. So I'm hoping that now you realize that by the end of end of learning about how to build these objects and axis types, that you really have a kind of a flow for how to build these graphs properly. And you can now see what I mean by stacking functions on top of each other in order to get it to look the way you want. We didn't even have to subplot, guys. We could put plots on top of each other and by using the same kind of logic where we're adding to a parameter every line of code. And that's a pretty efficient way to do it. We can do all kinds of styling, like changing colors and all that, and playing around with that. But with that, I think that is more than enough to understand for a section, because now you can look at the documentation for an axis object or for the type of plotting function you are doing, and you can create something that for any plotting type. You just got to look at the documentation. So with that, guys, thank you very much, and see you next section, where we're going to put this all together and try and create a graph from real data and do some more hardcore visualizing. So thank you very much, and see you next class.